Hello, everyone. Today, I intend to help you revise one of the most important topics in your GCSE exam, math exam, and this is connected to quadratics. Let's start with the general form of quadratics. They look like this: ax squared plus bx plus c. So that's the general form, where a is considered the coefficient of x squared, b is the coefficient of x, and c is obviously the constant. Let me give you some examples of quadratics. For example, 2x squared, that is your a, plus 3x, that 3 here would be your b, plus 5, that's a quadratic. When you equal this to 0, to another constant, or to another expression, you create an equation. But you don't know exactly what the result is, so we will say that that equals to y. This will help us to draw this quadratic, to see how it looks like on a coordinate grid. That's the general form. Let's stop right here, because this is what you need to know as it is, the general form, because you will need those coefficients a bit later. And in fact, let me tell you when you need those coefficients. You need those coefficients to calculate the roots, to apply the quadratic formula. And this is especially for the extended paper in IGCSE and a higher paper in GCSE. What else do you need to know? So that's the general form. You also need to be able to plot this quadratic on a coordinate grid. You need to be able to solve the quadratic. You also need to be able to factorize, and you need to be able to find the turning point. Sometimes they ask you to find the minimum or the maximum, but this is more for the higher paper. I'm not going to write it here though. So that's the turning point. And also quadratics are very useful, especially for higher paper and extended paper, to find the intersection points or solve graphically. So after you plot it, you have to be able to solve the equation graphically. Sometimes they ask you to say or to give the value of x when they give you the value of y. And they ask you to use your graph. So let's put it here: use your graph to find x when y equals to, sometimes they give you a constant, sometimes they give you a line. If they give you a line, you have to draw that line on the graph. I will dive into this a bit later. Also, they can ask you to draw the mirror line. Draw the mirror line. And this is connected to the turning point always. Also, they can ask you to give the coordinates where this graph meets the x-axis, or they ask you to give the coordinates of the turning point or the coordinates of the intersection points for different situations. All in all, let's start with the most difficult part. It's not difficult, it is a bit more complex because it involves substitution, and it's particularly harder for the foundation paper students. So for the students who sit foundation paper, this is a bit harder. Let's go into one example. They would give you this table. So now let's identify the quadratic first. The quadratic is here, y equals to x squared plus x. So when x is minus 3, y is 6. Why is this important? These 2 points are in fact the coordinates of one point on your parabol. So minus 3 would be the first point, and the other, the x coordinate, and the x would be the y coordinate. So that thing, that pair of values is exactly that, a point on a graph. So those are the coordinates of that point. Now we know that another point is minus 2, or negative 2. How can we find the y for this negative 2 in this quadratic? We just substitute that particular value into that particular recipe. You see, you change the ingredients. So that negative 2 to the power of 2 would be 4. Don't forget, negative 2 times negative 2 equals to 4 always. This is negative 2 to the power of 2. This is our x. This is what we have to substitute. So negative 2 to the power of 2 is actually minus 2 times minus 2, which is 4. And then you have to add the negative 2. So you will have 4 plus the negative 2, which is 4 minus 2. So it's 2. So the y for this x would be 2. Your next point on the coordinate grid would be minus 2, 2. Great. What happens when x is negative 1? Let's substitute. So negative 1 squared plus negative 1, we've just substituted as x by minus 1, equals to negative 1 to the power of 2 is 1. 1 plus minus 1 is 0. They have given us the value, so we don't need to calculate it, but just for you to see how this works. Okay, so this is the value, minus 1, 0. This is the next point. Let's go to the next point now. When x is 0, y will also be 0. Why? Because 0 squared will be 0, and plus another 0 will be 0. So our next point is 0, 0. Well, we've been given the other points on the graph. So let me write them down. 1 and 2. And then another one, which is 2 and 6. And the last one, which is 3. Let's calculate that one. So 3 squared plus 3. This is 9 plus 3, 12. So the last point will be 3, 12. Where did I put 13? 3, 12. Great. 3, 12. These are all the points that you have to plot on the graph. Now, let's try and plot them on the graph and see what comes up, what we will end up with. By the way, these are 2 marks each. So for this table, if you complete it correctly, you will get 2 marks. And for the graph, if you complete the graph correctly, you will also get 2 marks. All we need to do now is to plot the points. So let's start by plotting the first one, which is minus 3, 6. So negative 3 all the way to 6 here, right? So this is my first point. And then negative 2, 2. Negative 2, 2. It will be here. And then negative 1, 0. Negative 1 and 0, or minus 1, 0. And then the next one would be 0, 0. That's here. And then the next one will be 1, 2. 1, 2. And then 2, 6. 2, 6. And the last one would be 3, 12. When you enter the exam, you have to be able to understand that this is a parable. So you need to be able to remember that each time you see y equals to x squared or 2x squared or 3x squared, whatever, if you see that x squared there, you will definitely have to end up with a parable. So with a graph that looks like this. And if y is equal to minus x squared, you will end up with a graph that looks like this, upside down like that. Okay, in our case, it's y equals x squared plus x. So the graph will look like this. Okay, so let's try and plot it. But how will you plot it if you don't? Can you see the pattern here? I think it's quite easy to see the pattern. It's just that we need to be very careful when we plot it. So I will start. It was minus 3, 6. So it will go through all these points like this. And it will go a bit down here and then it will turn. And because it will turn, that will be called the turning point. See, like this. So here somewhere right in the middle will be the turning point. In between -1 and 0, our parabol will turn symmetrically. The symmetry line would be this one here. What's the symmetry line? This line has a very nice equation. It's x equals to minus 0.5. So this line goes through minus 0.5 all the way down, and it's the line of symmetry for this parabol. So what would be the coordinates of the turning point? Well, it's quite easy to see them here on the graph, but just to be on the safe side, we know the x coordinates, so x equals to 0.5 for the turning point. That's a definite answer because it's midway through -1 and 0, minus 0.5. So we will have to calculate the y just to be on the safe side. So if you don't want to calculate it, then you just look at the graph here, and it will be somewhere in between 0 and -2, closer to 0 than closer to -2. So minus 0.5 squared plus minus 0.5. 0.5 squared would be 0.25 minus 0.5. And this will give us negative 0.25. Okay, so this is negative 0.25. It's very close to 0. My drawing is not perfect. That's why never estimate it unless you are told to. And when you estimate it based on the graph, you have to be very careful not to miss or not to make any mistake. And this is it. This is how you draw it. Thank you for listening, and I will go on with the next question.